This video is going to be on finding horizontal asymptotes of rational functions. A horizontal asymptote is going to be a line that the graph approaches but never crosses most of the time. And first thing is you kind of got to know the way a rational function is constructed. So take f of x for example. A rational function is constructed by dividing two other functions. So for example, say p of x over q of x. You have these two functions and we divide them and they create a rational function. So for example, you could have f of x equals x squared plus 4 over 2x squared minus 2. And that's an example, right? We've seen in class we've had to graph x squared plus 4 and we've had to graph 2x squared minus 2. And so you create a rational function by dividing them. And so there's two things that you need to know before we give the rules for horizontal asymptotes, because to find horizontal asymptotes you just really need to know rules. And so everybody's favorite, before we do that, here's a little bit of vocabulary. M is the degree of the numerator and n is the degree of the denominator. So m is the degree of the numerator, n is the degree of the denominator. So in my example over here, 2 is the degree of the numerator, so m is 2, and 2 is also the degree of the denominator. It's the highest exponent there, and so n is also 2. So m and n are the same thing in this problem, and we'll see how that affects the horizontal asymptote. So 3 rules, and here they are, okay? The first one occurs when m is less than n. The next one occurs when m is equal to n. And the third one occurs when m is greater than n. If the degree on top, the degree of the numerator, is less than the degree of the denominator, then the horizontal asymptote is always y equals 0. Doesn't matter. Always y equals 0. The next one is when the degrees are the same. The way we figure out the horizontal asymptote is we divide the leading coefficients. Okay, so we divide the leading coefficients. And so let's take a look at the example I made earlier. If you look at the leading coefficients, that's the numbers in front of the terms with the degree. So 1 and 2 are leading coefficients, so we divide those. So the horizontal asymptote, would be 1, or y equals 1 over 2, which is 1/2. So the graph would approach 1/2 but not cross it. And then finally, the last one is when m is greater than n, the degree on top is bigger than the degree on the bottom, then there is no horizontal asymptote. Okay, and those are your 3 rules for horizontal asymptotes. So let's take a look at a couple examples here. First one we'll go with is y equals 2 over x minus 4. What you need to do is you need to determine m and n. If you can determine both of those, then you will be able to apply it to whatever the rule is. So tough one on these ones is the numerator doesn't have an x. So a lot of people get thrown off as to what the degree is. But if it's just a constant term, then the degree is 0. So m is 0. And then this does have an x, so the highest exponent here is 1. So as we compare them, 0 is less than 1, and so we want to use that rule. And so the degree is less than on top is less than the degree on the bottom, so we can say that the horizontal asymptote is at y equals 0. And it's just a case of you memorizing the 3 rules. The next one, let's take a look at the next one. Next one would be y equals 2x minus 5 over x plus 3. And if we take a look, m is 1 and n is 1. So since they are equal, we want to divide the leading coefficients. 2 is the leading coefficient and 1 is the leading coefficient. So the horizontal asymptote would be y equals 2 over 1, which is 2. And let's do one more. Make it a little crazier. So here it is, y equals 4x squared over x minus 1. And we identify the degrees of numerator and denominator. So m is 2, and n on the denominator is 1. And since the degree on top is bigger than the degree on the bottom, there is no horizontal asymptote. All right, have a great day.